The event is now live. John, please take it away.
Thanks, Annie. Hi, everyone. Welcome to the latest installment of our ongoing editorial webinar series, Coffee Talk. Each hour-long, information-packed episode organized by the hardworking folks at Redmond Magazine features the observations and insights of an independent expert on a wide range of tech industry topics. Many thanks to the underwriting sponsor of this episode, high-performance enterprise networking solutions provider Juniper Networks. It's their support that makes this event possible. And thanks to you for joining us. I'm John K. Waters, Editor-in-Chief of the Converge 360 Group of 1105 Media, and I'll be your moderator. Today's topic is AIOps and the Network Visibility Imperative. And our main presenter is technologist, creator of compelling content, and senior resultant, Howard M. Cohen. Before we get started, though, just a bit of housekeeping. This episode is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way in the next few days. We'll make some time during the talk for some questions, so please feel free to type your questions into the Q&A box at any time. We'll do our best to get to all of them. Our sponsors provide us some extra resources you won't want to miss. They're available now on your console. And as a small thank you to the first 200 attendees who stick with us to the end, we will be sending you a $5 certificate to Starbucks. It's a cup of joe to go with the info. Now I'd like to introduce our first speaker. In his 40-plus years in the IT industry, Howard has held senior executive positions in many of the top channel partner organizations, and he currently writes for and about IT and the IT channel. He is a sought-after speaker, an insightful observer of the technology landscape, and one of our very favorite presenters. You're in for an awesome session. Take it away, Howard.
Thank you so much, John. You know, we're going to have to work on my intro. I just realized it makes me sound like I'm old and can't hold down a job. But we'll see what happens. Hello, everybody. What can I tell you? Welcome to today's session on, what are we doing today, John? AIOps and the Network Visibility Imperative. I'll stop kidding around. Okay. Those of you who have been with me before on any of these presentations know that I love to start each presentation with a word of the day. And today's word really relates strongly to the importance of AIOps and network visibility because they both really depend upon it. And it's a challenge. The word, of course, is speed. And when it comes to network monitoring and network management, there are three things that we're concerned about. And they're the same three things that we're concerned about when we're handling big data, which makes sense because what crosses the network? Big data, maybe small data sometimes, but the three things that we're concerned with are volume, velocity, and variety, the three V's. Just taking a quick look at each one individually. Let's start with volume. We're talking about a volume of traffic crossing the network. And in today's networks, especially with big data, with more and more devices and people and companies coming online, the amount of traffic crossing the network just continues to increase. But we're still expected to manage it as well as we ever did. Now, along with the traffic comes from users. There are more and more users getting on the network and doing more things, and quite frankly, doing more sophisticated things than they've ever done before. Those users turn to devices to connect them to the network. And of course, the users are not alone. A lot of devices are on the network all by themselves in the Internet of Things. So we have more things than we have people on the internet at this point, and they're distributed amongst more locations than they ever have been before. So we're tracking more locations. Now, all of this, from the perspective of those who are monitoring and managing the network, create more telemetry. There's more telemetry coming in from more places, more devices, more users, so forth and so on. And that means that we're generating more and bigger logs than we ever have before. because every transaction that happens on the network is getting logged so that we can analyze it and figure out what happened when we need to. Logs are also tracking applications, and there are more and more applications coming online all the time. There are more and more sophisticated applications that do more. And of course, they use lots and lots of data that also needs to be tracked. So there's a large volume of things that there are a large volume of. And it's getting bigger. It's just getting bigger. Next up, let's talk about velocity. Okay, velocity, how fast we can move all that data from place to place to place absolutely depends upon how much bandwidth we have. How much data can we squeeze through the pipe? Can we get broader pipes, bigger pipes? In some cases, we're using better and better compression to shrink down the size of the data that we're transmitting, but there's a limit to that, just like there's a limit to how small Ant-Man can get. There's a limit to how small your data can get. We're trying to improve upon the protocols that we use to transmit and receive data back and forth, and there's constant development going on in that, but we're always battling latency, things that slow down the data flow, things that get in the way of the data flow. We're trying our best in every way that we can to reduce latency. And finally, there is the issue of variety. We've got a lot of different data types. Applications are now sending all manner of data types, from simple text to telemetry to sound and video, and many, many more. So we have to figure out how to deal with each of those data types. We have more and more remote users in more and more locations than we've ever had before. Turns out that work from home stuck, and a lot of people love it, and a lot of managers love it. A lot of people who run companies love work from home because they're getting more productivity out of their people than they ever did before. Who knew? So we have all these people out there connecting in various different ways, and we have to be able not only to see each of them, but we also need to secure each of them. Along with that, we have more and more cloud services coming at us. Each of the hyperscalers keeps on introducing new services, so their service menus are getting up into the thousands of different services. Add to that all the hundreds of thousands, perhaps millions of cloud services that are commercially available around the world. Each of those generates plenty of traffic that needs to be tracked. When you talk cloud, you have to talk about hybrid cloud, adding complexity. So now you've got some public clouds and some private clouds, and you're tracking both. And there's a difference. There's a difference in protocols. There's a difference in idiosyncrasies, if you will, amongst them. And of course, as if that wasn't complex enough, we've introduced multi-cloud. So not only do we have one hyperscaler, we have two or three. Not only do we have one cloud service, but we have 10 or 20, and they're similar, but they each have a different feature that we want. Now we can combine them, so we do combine them. Of course, on top of that, adding to the variety and volume of traffic moving around the network from cloud to cloud to cloud, more and more of us are developing our applications using microservices in containers. And that traffic is tremendous. So the responsibility for managing networks and securing networks becomes extremely challenging because there's so much to track. And of course, the real management challenge that creates the visibility imperative is the simple fact that none of us are the Flash. None of us are that fast. There's no way that we can keep up with the real-time logs that come rolling in all the time. By the time we find something out of sorts on a log, it may be days, weeks, who knows. So we can't keep up with the flow of data and protocols and other traffic running across our networks. At this point, I'll remind you all of what our good friend Peter Drucker told us. If you can't measure it, you can't manage it. So the fact that we can't see the, or we can't keep up with the data means that we really can't measure it properly, accurately, or in a timely fashion, meaning we can't manage those networks. Now, this is aided, of course, by a corollary that's been introduced to us by another good friend, the Invisible Man, who says if you can't see it, you can't measure it. So if you can't see it, you can't measure it. If you can't measure it, you can't manage it. We're in a real challenge. And I think that challenge is best summed up in the wisdom of the Karate Kid, who says if a man can't see, he can't fight. And that goes for women too. If you can't see, you can't fight. And so we need to figure out, how do we capture all that detail? How do we keep track of everything that's going on in the network? Okay, let's start by looking at what has been up until now. Up until now, we've all worked in traditional network operations centers. Yours may not be this big, but it's probably configured in a similar way. There are some large screens up in front of you that are tracking the core data and the most important factors, and you can look up at them and see what's going on, and that's great. In addition to that, however, you have a group of monitors in front of you, and they're showing you more specific data that you're responsible for seeing, assessing, and acting upon. So what do you see? Well, you see all kinds of traces going past you. You see data rolling past you, and it's generally moving very fast. So fast that you may not have time to analyze what it means to you, and you may miss things. Things may just slide by the screen before you even catch them. If you look up at the big screens, you may miss something on the small screens. Also, you have logs flying past you in just data scrolling and scrolling and scrolling and scrolling. So how do you keep up with all of that? And the answer is, of course, you can't. You can't because we're not the Flash. None of us can move or perceive things that quickly. However, even though we're not the Flash, whoops, that was great. Sorry. Even though we're not the Flash, AIOps is the Flash. AIOps moves as fast as the Flash. It moves at the speed of thought. It's just incredibly fast. It can keep up with the data. It can keep up with the logs. It can keep up with the traces. It can keep up with all the telemetry. Not only that, it can do far more. Now, quickly, let's just jump in and define what we mean by AIOps. AIOps is simply artificial intelligence for information technology operations. If you operate a network in any capacity, this is technology that was built for you, applying artificial intelligence, machine learning, cognitive capabilities, all to the task of visually monitoring and functionally managing your network operations. So the big key value that we've been talking about is visibility. And indeed, with AIOps to help you, you can see every device, every user, every application that's running, every protocol that's in use, every data entity that's in use, and by whom and for what. And all of that can be tracked because artificial intelligence is on the job. Not only that, it can alert you when something isn't the way it's supposed to be. And so visibility is just one of the things that AIOps gives us. There is another, and that is observability. We can not only see these things, but we can actually see what they're doing and what's resulting from what they're doing. Now, from the perspective of a user, that becomes very important. Users' expectations have skyrocketed over the past few years. It used to be that you can tell them, okay, we know it's this and this device, and it's spewing out too many packets, and we've got to figure out why it's signaling like the way it is. And the user is sitting there thinking, I don't really care. Just fix it. Well, nowadays, that just fix it is the rule. They expect that you will fix it before they call you to tell you there's a problem. And you know that. I'm telling you something that you know. So you have all this telemetry coming in. With AIOps on the job, all of that telemetry is coming into your data platform. And your data platform performs all kinds of analyses. It does a root cause analysis, so you can trace back what happened, why it happened, where that was caused. You can also start to look at adjacent systems and why conditions in those adjacent systems may have contributed either to the problem itself or perhaps to the severity of the problem. So you're getting a lot of analysis there. And the last thing that the data platform is responsible for is identifying and formulating a solution. And it feeds that solution back so that you can take action immediately, so that you can fulfill your user's expectation and get them back to work instantly. So it's not dependent upon you and your imagination and your experience to come up with the solution. No, the data platform, using the observability furnished by the artificial intelligence and machine learning, that actually solves the problem and makes you a hero with your users. Of course, what presentation would be complete without a reference to the Gartner Glossary? And in this case, I went to the Gartner Glossary to hear what they have to say about AIOps. And Gartner says AIOps combines big data and machine learning to automate IT operations and processes, including event correlation, anomaly detection, and causality determination. And that's a fairly robust sentence. There's a lot in there. Let's unpack it just a little bit. I noticed that they don't mention artificial intelligence because it's already mentioned in the contraction, AIOps, and it's very good. Obviously, the big data is the data that refers to your network, every device that's on it, every data asset, every user, et cetera, et cetera, et cetera. In terms of automating IT operations processes, event correlation means this happened. Let's figure out what else was going on when this happened and how it may have caused this to happen. Anomaly detection. Something is not the way it's supposed to be. One of these things is not like the others. Okay, you want the technology to do that because it's all too easy for humans to miss it. Again, we're not the Flash. And once you've figured it out, yes, you want to certainly go and fix it, but you also want to know what caused it so that later on you can change that, fix that, so that the same problem doesn't happen again. So the components of AIOps begin with real-time performance monitoring. There are sensors and software throughout your network that are monitoring various different features of your network, including the traffic going through your copper, fiber, and wireless network segments. There is anomaly detection with root cause analysis, solution development, all faster and more accurate than is humanly possible. Meaning we don't just look and say, oh, there's a problem. We figure out what caused the problem. We develop a solution for that problem, and we do all of that faster, which means that we're catching issues that humans might miss that are buried. And again, we go back to the volume, the sheer volume of data. It is all too easy for a human being to simply miss an anomaly flying by in all that data. Now, we're detecting and observing these anomalies across a local area network, wide area network connections, cloud connections, and more, including monitoring of the routers, the switches, wireless, firewalls, software-defined wide area, and most recently, secure access. Wow, here it goes again. Secure access service secure access service edge, and more. I mean, there's a lot of technologies I'm not mentioning here, but you get the idea. We're not isolating ourselves to one segment of the network. We're responsible for the whole thing, for the data getting from wherever it started to wherever it's supposed to end up. Again, I'm going to emphasize the importance of the underlying problem. We can go chasing after the same problem again and again and again and again, and ultimately somebody's going to kind of look at us and say, well, what are you doing? You know, you're solving the same problem. That's the definition of insanity, doing the same thing over and over again and expecting a different outcome. So we go looking for the underlying problem. We perform much deeper analysis so that we can understand what caused this problem, fix it, and not have to deal with this problem again. And again, resolving immediately the problem that existed, leveraging automation to do it, and thereby accelerating the mean time to resolution. When you've accelerated the mean time to resolution, you've also accomplished something else that's extremely important, which I will get to in a moment because I just realized I inserted something about DevOps. Those of you who have initiated a DevOps culture in your company know that the DevOps team is responsible for creating and deploying software updates constantly and as quickly as possible. And there are companies that are now updating their software 200 or 300 times a day. So they have to be moving very quickly. And therefore, they can't afford delay of any kind. Now, there are many things that can delay the DevOps team. And if the ops side of the DevOps team is delayed, well, you bet that's going to delay the dev side of the DevOps team. So we have to be able to get in front of operational obstacles, things that might occur that would slow us down in deploying the next iteration. We have to be really forward-thinking in identifying anomalies that might make it more difficult to load these new iterations of software and get them up and running. And all of that, not only is it there to make the users operate more productively, but also to optimize our spending on IT. Yeah, faster, better should also equal less expensive. Ultimately, by leveraging AI and ML, we create less noise in the environment. There's less to have to pay attention to. There are fewer alerts. You know, there's more smooth operation. And because we're getting better responses from our telemetry, we achieve more clarity for the operations people. So they know exactly what's going on the network when they go to deploy the next iteration. They also achieve a greater depth of vision. You know, most great operators, most great network engineers can take the data and visualize from it and determine what are the things we should do to improve the network overall. What have we not yet done? And hopefully this surfaces issues that do require that deeper level of improvement that they can add. So now we finally get to that last point I wanted to make. Sum it up. When we use AIOps to help us with the visibility imperative, We can see all the incoming traffic. We can see all the outgoing traffic too. We can analyze it instantly, which helps us determine causes in real time, creates solutions in real time so we can resolve problems immediately. If you walk away with nothing else today, just remember that concept. AIOps takes you from visibility to resolution very, very quickly. And that provides the all-important feature of enhancing your user's experience. Because ultimately, that's what we're all here for. We're here to make it work better for our users so they can get their jobs done faster, more efficiently, so that products can be turned out faster and efficiently, and therefore corporate profits increase. With that, I'm going to turn it back to John to see if we have any questions.
We do. We have quite a few here. Let me remind everyone that you can type your questions into the Q&A box at any time. We'll do our best to get to all of them. Let's start with this question from Lynn James. Hi, Lynn. Welcome. Lynn is a frequent flyer.
Frequent flyer.
And the question here is, can you, and always good questions as well. Can you explain how AIOps leverages AI and machine learning to analyze and interpret network data for better insights?
Oh, yeah. The problem with Lynn's questions is they're always way too deep, and I don't have the hours it takes to explain all that. I will say, however, that our next presenter, JD, is going to take you through some of the technologies and may offer you deeper insight into how it's done. To explain AI would take, to explain AI applied to network operations. Lynn, I would love to be able to go through all that, but I think JD is going to be more qualified and hopefully can give you more.
Okay, we've got a good question here from Jennifer, who asks, does faster, better always pay off in the end? Couldn't that be a recipe for rework?
Ooh, that's a great question. Well, if it were people working faster and better, sure, people make mistakes. You could say that moving faster increases the likelihood of mistakes when you're talking about a human, but really, when you're talking about digital devices, it's not the same thing. Digital devices do the same thing the same way every time. They're as reliable as can be, unless something breaks, in which case everything comes to a halt. But that's not what we're talking about. So using automation to get things done faster and better means that people are freed up from those things and can do things that take more concentration and take more time. And so they can enjoy a better quality of work that's more rewarding to them. Hope that's responsive to what you meant.
Okay, here's one from Zeke, who's wondering, Howard, is AIOps based on ChatGPT?
It depends on whose AIOps you're talking about. ChatGPT is one implementation of an engine that uses large language models. There are many. ChatGPT has done a better job of getting their name out there. But again, I suspect, I'm not sure, but I think JD will probably talk about that in the course of the Juniper presentation. At least I hope so. I'd like to learn more about it.
Okay, here's one from Annie, who's wondering, Howard, what market segment do you think AIOps is most appropriate for?
We've got a salesperson in the mix. Okay. That's a great question. I think logically, you'd instinctively think that the automation would pay off most in a larger network. And a larger network is probably operated by a larger company. So I think it's easy to say that, Fortune-sized companies, mid-range sized companies that are, really substantial and have plenty of need for IT, have plenty of need for AI ops to make that IT more efficient. But that doesn't, I just want to point out that doesn't cut out the smaller businesses. There are smaller businesses that are basing themselves on technology, that are leveraging technology to make it possible to do what they do. And if it's that critical component of their business, yeah, I would think they'd want AI ops too. So yeah, bigger, bigger, maybe smaller.
Okay, we've got time for one more here. This is the question is, Howard, will AI ops eventually replace human network operators completely? The fear in the pit of all of our stomachs.
In front of all these people, I'm going to say no, because otherwise they might come and hurt me. Will it completely? Well, it's true. I can give you two answers to that. One answer is that I still believe that networking, I mean, one of the things that attracted me to technology and to digital devices and to networking in the first place is the fact that imagination counts. You can use your imagination to create new things and to expand upon things. And so I don't see a day yet where AI will feature imagination. That is not to say that it never will. I mean, Bill Gates, Elon Musk have actually agreed with each other that where we are today is nothing to worry about, because AI can perform useful, positive functions, but it's only of moderate intelligence. There will come a day when they achieve super intelligence, and that's when we need to worry. So at that point, I guess all bets are off. I don't know what will happen then. But then again, two of the most brilliant men in the world don't either. So good company.
Fascinating. Well, as one of those with moderate intelligence, but hopefully performing a useful function, I want to introduce to the attendees our second speaker, Jonathan Davis, Solutions Marketing Manager at Juniper Networks. JD is a certified wireless network expert and trainer with certifications from Cisco, CWNP, Ekahau, Aruba, and Juniper. He's a regular delegate at Tech Field Day events, and he's a co-founder of the Wi-Fi Award, which were created to recognize top companies and individuals in the Wi-Fi community. He joined Juniper after 2 decades as a customer in technical engineering roles, and he speaks and writes often about technology. We're lucky to have him with us today. You're in for another great session. Take it away, JD.
Hello, everyone. And first of all, let me just say, Howard, great presentation. And I'm loving the questions that are coming in. You guys are asking all of the right questions, and it's obvious that you're thinking about this in the right way. I hopefully will answer a lot of these questions as we go. I went ahead and made notes of a couple of them just in case, and if not, at the end, I'll be certain to grab them. So one of the things in the introduction there, the thing that was called out was the fact that I left being an engineer and I am now working for a manufacturer. I left working for the customer, and now I'm in the dirty role of working for a manufacturer. And why in the world would I do that? And I think it really boils down to seeing AI ops in action and believing in the product, because what you're going to see is what we do every day. And this is AI ops realized. It's not the promise of what's coming. It's what is here and how it affects us. So let's jump right into that. So why AI ops for customers? And also too, I think, the question that gets asked a lot, you'll see a lot of commentary on it. You'll see people ask questions. You'll see people write articles about it. And I think and we just had that question, will AI take my job? Right? That's something that we're all kind of questioning about this. And I want to be clear, if AI takes your job, you probably weren't doing enough in your job. The reality is no, AI is not going to take my job, but there's a bigger question here. And I think when we ask that question, we'll really start to see the value. But before we do that, what I really want to do is I want to kind of change the way we think about this. We heard a lot about network automation over the last last decade and a half. Really, we kind of started out in that day zero, day one mindset of how do we deploy devices faster. Maybe those are servers, maybe they're switches, maybe they're, piece of hardware du jour. It really doesn't matter. How do we do it faster, and how do we ensure that we're deploying it the same way every single time, right? So that's kind of where this started. And then we kind of went further and we said, okay, let's make changes in the same manner. How do we make the same change across 500 sites in a shorter period of time, ensure that it happens exactly the same way every time? And ultimately, the reason we're doing this is so that we can move faster, as Howard mentioned, that we can accomplish more with the same head count. And so now when we start thinking about AIOps, what I want you to begin thinking about this is really just kind of network automation phase 3, where now we're moving automation in some manners into problem resolution. Now, it'll be assistive. It's not going to be, it's not going to fix all of your problems. I want to be clear on that. But it's going to make that process that much easier and go that much faster, so that ultimately you can focus on the things that matter. So instead of asking the question, will AI take my job? Let's ask the question, how will AIOps improve my job? Because ultimately what we're doing, what many of us are asked to do is meet a series of goals that generally have to do with network improvements, while also juggling the day-to-day minutia that comes along with simply supporting a network. Before joining Juniper, I was at a large university. We had over 40,000 wireless clients. We had almost 11,000 access points. And it was a lot of juggling, because trying to manage that size network while also solving the day-to-day issues, even for a reasonable sized team, takes a lot of time and a lot of effort and energy. So let's start asking the question, what happens if we empower our help desk to troubleshoot and resolve problems that technically may be above what they can solve and resolve today? If we look at over on the right, if we kind of look at this conversation that's taking place with our Marvis AI conversational assistant, what we see first is the question is asked, please troubleshoot this client, and we give it a client name, right? So in this case, it's Miss PI 16. We could also give it a MAC address. We could give it different things, right? Because we know this is a client that someone's contacted us about. And we get back in that chat, we say, hey, we found 3 problems that could potentially be issues here. But the one that really kind of comes to the top, 23% of the time, it failed to connect. And the reason is there was an authentication problem. And that authentication problem happened because there was a WPA 4-way handshake timeout. Now, I've done a lot of wireless. I don't have to go any further than that. As soon as I see that, I go, okay, this is we see it's PSK. This is obviously someone's entering the wrong password. And this is something you can really easily teach your service desk. This error means wrong password. Or you can then click on failure timeline and see more, and that's when you'll actually say, okay, yes, this is a bad password for a pre-shared key network. We can also look at other things like, are there other impacted clients and things like that. This is a really basic, straightforward troubleshooting scenario. But what about radius, right? If we think about an 802.1x radius authentication, and we think about a client that's trying to connect to the wireless network, if we use this same example, what could break? What could go wrong to keep that client from connecting? Well, it could be a Wi-Fi problem. It could be an access point that isn't available when it should be, something along those lines. It could be a LAN problem, and that could be PoE issues causing that access point to restart. It could be something like a VLAN is not trunked correctly. So the access point is up and working, but whenever the client gets assigned into the VLAN, which we'll see here in a bit, there's an issue. It could be an IPAM or DHCP problem, right? So maybe it's getting assigned the right VLAN, but the DHCP pool is out of IP addresses. It could be that the server that the DHCP server is running on is having problems and isn't responding. And as you can see, there's a large list here. All of these things could affect whether or not that client connects. And generally, in a standard non-AIOps enabled network, this generally is going to be, okay, it's going to be sent directly to the Wi-Fi team because it's ultimately not the service desk person's responsibility to troubleshoot, and generally they don't have the capabilities or the authentication to troubleshoot all of these things. And so they're going to send it off to the Wi-Fi team, and then that team is going to be responsible for troubleshooting far enough to then find out who it should actually be assigned to, right? And that's a problem because now we're extending the amount of time it takes to fix the problem. And when ultimately, if instead the response comes back and says, hey, this server is not responding to request, well, guess what? Now, whenever the service desk or the help desk forwards the ticket, they send it directly off to security or they send it off to the systems because now we know, okay, this is a Radius server that's not responding, and Radius services are managed by the systems team, not the Wi-Fi team. So these are the types of things when we talk about doing more faster, these are the types of things that AIOps enables. Let's also talk about what does it mean when we say a normal operation in a network? We at Juniper, we have these things called service level expectations. It's very much like an SLA, but in this case, what we're saying is based on what the data provides, this is what should be expected in the network, right? And so, Howard talked earlier about kind of that high signal or less noise, more clarity is specifically what he said. I of course, as a Wi-Fi guy, think of this as SNR, signal to noise ratio. It doesn't matter how strong the signal is. It doesn't, if you're at a rock concert, someone can be screaming in your ear and you may still not be able to hear them. And sometimes the problem can be screaming in your face and you not be able to see it for exactly as Howard said, all of the logs and everything that you have to look at. So what we want to do is we want to be able we want to show you this is normal for your network. Right. Here are all the things that generally take place in your network. And here's a 7-day running, a timeline of what that looks like. So, for example, you can begin to see, okay, normally we have, great success with time to connect. But this fell off, a few hours ago, and we're starting to have, users call us, but this has actually been going on a little bit longer, and maybe there's a bigger problem that's affecting more than just these 3 users that's called us. Or so another good example to think about here is if you have clients that are connected across a long WAN link, and let's just say they're in another country and they have really high latency for radius responses, you don't need to know that they always have high radius responses. You don't want to begin troubleshooting a high radius response or high latency in radius responses if that's not the problem, because at that point you're troubleshooting noise, you're not troubleshooting the signal. So we have to understand what is normal behavior so that we can then understand what is abnormal. We have to be able to highlight those changes really quickly whenever the problems occur and understand when they begin. We have to understand the scale of the problem. Is this a one user problem or is this all the users' problems, right? Because that, again, helps us begin to troubleshoot, where the, at what level do we need to fix or do we need to troubleshoot from? And we have to be aware of that poor performance before tickets are entered. This is something you'll see again here in a minute in ways that we are able to do that. So the kind of the next step that we have here that comes in with this is Marvis actions. So Marvis actions are where we find issues for you and we actually present them to you before they are actually identified as problems usually. So we can discover and in some cases correct issues before the users complain, or at the very least, we're going to suggest a change to you And as an example, so we have a customer, a very large customer with a ridiculous number of access points and a ridiculous number of switches across a multinational network. And whenever they turned on Marvis Actions, what they found is they found, I believe the number was seven VLANs that were not correctly trunked between switches and access points. Now, if you think about this, when you're talking about, let's just say 7 access points spread across distribution centers across the world, from a user perspective, their experience when they encountered one of those access points would be a bad roam. They would get into the area of that access point, the AP, they would authenticate to the AP, or maybe they were pre-authenticated. It would say, you have to connect to this VLAN. They would be assigned to the VLAN, but that data all gets discarded because that VLAN doesn't exist. Most likely they're still moving. If you've ever been in a distribution center, you know they zip around all over the place. And so they have a disconnect, but likely they don't even see the disconnect until they get to the next place that they're actually doing work from. And all they see is a disconnect. It's a really, really spotty, hard to find problem. But whenever they turned on Marvis Actions in this case, we brought the problem directly to them as, hey, here's an issue that you need to fix on your network. And none of their other monitoring tools were able to find this for them. So when we talk again about that less noise, more clarity, or that high signal to noise ratio, and that ability to improve customer satisfaction, but also IT satisfaction by making it easier to solve these problems faster, this is what we're talking about. So how will AI improve the user experience, right? We've got that faster mean time to resolution we just discussed. We've got network or system-wide problems are resolved before they become issues, before the users start to complain, which is huge. We lower the troubleshooting overhead, which ultimately increases our opportunities for service enhancements, right? Because if you're constantly fighting a forest fire day in and day out of user complaints, you will never get time for those service enhancements that ultimately will maybe keep those complaints from coming in, or more importantly, just the day-to-day life cycle management and other things that come along that are part of our roles. And then, of course, the last part of this, and honestly, I can't believe I didn't include a screenshot here. When problems occur, we have a dynamic packet capture that ensures that the relevant information is saved. So earlier I mentioned an example of a Radius client that wasn't able to authenticate. We're going to have a dynamic packet capture of that actual event. Now, I want to be really clear. There are a lot of competitors out there that kind of have some similar claims. And one of the things they'll talk about are customizable packet captures, or capture filters, or various things along those lines where you can say, okay, I have this user who's having this problem. If this problem is occurring, capture it, right? And it just kind of, for that user, after you set it up, it just kind of, keeps a buffer going, and then, oh, here, this thing occurred, and so therefore here it is. What we're telling you is we already have that. You didn't have to configure anything. We have the packet capture already, and we can actually, you can download the PCAP, you can open it up in Wireshark or your software of choice, and it's going to be there for you. So I think an important question here is AIOps a standard? Because we're kind of talking about it as an industry term, and I want to be really clear on this. It absolutely isn't. All of the different companies that are out there, we're all kind of addressing this from a different perspective with different views on what's important and what isn't. And I think it's really important to understand that when I say I left being a customer, which was something I loved, to come join Juniper because they got it, this is really what I mean here. When you look at our competition and what they're doing, and if you guys are interested in becoming Juniper customers, or at least having that conversation, absolutely, when it comes to time to do it, do a POC, do it, put us on site in one of your buildings and see what this actually looks like real time with real data. Because if you compare that with what our competitors are doing, what you're seeing is that they already have a platform that they're invested in, and they're doing this lift and shift from the controller architecture or from their management server system into the cloud. And so rather than actually building this for the cloud, they're doing this lift and shift that ultimately is the wrong way of doing it. And it ends up with, you bring old technologies with you when you do that. One competitor, when they were, and this was literally just happened just a couple of months ago when they were asked about their latest quote unquote next gen platform, they admitted that it was 100% new UX UI. So what it looks like is brand new, no question, but 70 to 80% existing underlying pipeline. So all of the architecture was said, well, 70 to 80% was the same. And this was their admission, their public admission. This is out there publicly. There's also a lot of issues with licensing confusion between the really old, and the latest architectures. Can you bring your licenses across? What does that look like? Do you have to upgrade? Do you have to pay to upgrade them? A lot of different things like that. And a great example of this, again, kind of the fact that they're not all created equal. One of the best new AI features that one of our competitors out there has put out literally tells you which bit of code, like which version you should update to, so that you can avoid all of the bugs in their code. That is unsustainable. That is not AIOps. Let's be very clear on that. And you're also seeing situations where their management system updates are requiring hours-long outages for all users. That is not AIOps. So why Juniper then? Of course, the corollary of that is we started as AI first, right? We use a combination of AI, machine learning, and data sciences techniques in everything we do to ensure that we are providing the right data at the right time for the right users. We ingest data from access point switches, session smart routers, and firewalls to come to the conclusions that we do. Howard did a great job of kind of talking about all of the various things that can, all of the noise that ultimately gets factored in, and we find the signal in that. Marvis is the first item Juniper missed AI support personnel checks to resolve customer issues. This is key. You've heard the phrase, eating your own dog food. This takes it a step further. If a customer contacts us with a problem, we first go see, does the missed AI, is it aware of the problem? Can we find the problem there? Because if we can't, what that says is we aren't doing our job fully. We've got an improvement that we need to make. And so we're always working to further improve the what can be fixed and what can be solved through that platform. We are microservices, cloud-based architecture for agility and scale from day one. We aren't doing a lift and shift. We're not trying to change the wheels while it's going down the highway. This is the way we were built from the very beginning. And for that reason, we can do things like we can deliver updates twice each month, almost every month, without any service impacts. This is so it's no longer a question of, am I going to be 6 months or a year behind the latest and greatest just so that I can avoid bugs? We're already delivering those things continuously. So ultimately, that is what Juniper Mist AI looks like. That is what AIOps looks like when you're a Juniper customer. I think there was a really important question earlier that I don't think I did a great job of answering. I want to answer that really quickly. And the question was, does faster and better always pay off in the end? Couldn't that be a recipe for disaster? True machine learning, one of the things it kind of incorporates is kind of a reward system for the system for when it's right and when it's wrong. And so whenever it's kind of making, understanding, okay, this is going on based on all of this noise, this most likely is happening, there is an inbuilt reward system that kind of corrects it and helps it learn and helps it further kind of dissect that data in the future and have a better understanding. So I think that's really important to understand when we talk about this isn't automation like I brought up originally. This isn't your standard automation. This is a learning, growing system that automates bringing that noise floor down and that signal up. And with that, I want to say thank you to everyone. I'm happy to answer some questions now.
Awesome. Thanks, JD. Now let's get to our second Q&A. There's still plenty of time to type your questions into the Q&A box. Let's start with this one here. JD, can Marvis detect problems on non-Jupiter network equipment?
Okay, that's a great question. So we can detect. So for example, if you think about all of the information that gets shared between devices, no matter who the manufacturer is, we can absolutely detect things like any information that's shared via LLDP. We can obviously we understand what's happening with trunking and routing and things along those lines. So we can detect from that perspective. You can't license Marvis for your other vendor du jour network and let it then manage that network. We are an inclusive, cohesive environment, and so you absolutely need our hardware to get the full benefit, but we can absolutely understand what may be happening when our hardware touches a different vendor's hardware, and we can absolutely help in that troubleshooting process.
Okay, here's one. Is dynamic packet capture automatic, or does it need to be configured to capture the correct packets when problems occur?
Yes, so it is absolutely automatic. We actually have, when a packet comes in, it gets tossed into a ring buffer. It gets processed normally, but it also gets tossed into a ring buffer. And that buffer ensures that we hold on to that until it's no longer needed. So in this case, and for those who understand the frames, it's the there's no data. It's only the headers, and so we ensure, for example, that the conversation is completed, that those types of things take place, and then we drop it from the buffer. But in the situation where we have a half open session, or we have a timeout that occurs or something along those lines, we're still hanging on to that packet. And for that reason, and that's the reason that there is no need to configure, specific packet captures to capture something, something going afoul. We have the intelligence and to identify the issue, and we already have that packet capture that we took real time.
Fascinating. Okay, here's one. We've got time for, looks like one more. Is Marvis just another wrapper for ChatGPT?
All right, that question's come up a couple of times. So first of all, Marvis was announced several years ago, long before ChatGPT became the noise machine that it currently is. And so, to be very clear, it absolutely isn't. This is something that was built in-house. However, we have actually recently announced some really cool integration with ChatGPT. So through the same engine, we actually we integrated our documentation. So you can ask essentially a documentation or a configuration question, things along those lines that you would normally maybe be looking for, on our support website, somewhere else. And we are using ChatGPT to answer those specific types of questions. So we have integration with, but the Marvis intelligence that you saw and all of the other intelligence that you saw is in no way associated with ChatGPT. It is a very custom and pretty amazing system.
Well, it looks like that's all the time we have for this episode of Coffee Talk. Many thanks to Howard M. Cohen for an insightful presentation, and to Jonathan Davis, JD, for joining us on this informative episode. And a special thanks to Juniper Networks for sponsoring us. We couldn't have done it without them. Keep an eye out for our next episode and for your Starbucks gift card. It should be coming your way in the next few days. Thanks, everyone, and have a great day.